So welcome everyone to this latest Zero Carbon Mine webinar. Today we've got David Pearce from SRK here to give a presentation on how to eat the decarbonisation elephant. These Zero Carbon Mine webinars are really about educating and sharing knowledge around the mining decarbonisation space. So open to all sorts of topics, but I think we'll try and hold any questions to the end, but there should be plenty of time for Q&A at the end, and I'll hand it over to Dave to take from here.
Thank you very much, Brett. So good morning, good afternoon, good evening to everybody. Let me get going. So I'll just share my screen. So I hope everybody can see the screen. So I'm a mining engineer, so my focus is going to be very much on the practical steps that are being taken. So I'm not going to be talking too much about the theoretical options. I'm not going to talk too much about the whys and wherefores. My intention is to focus very much on what can be done. All right. So first question, why am I giving this? Well, I'm a mining engineer and I'm a consultant. And the principal reason about talking about the decarbonisation is because I believe passionately that an engineer's job is to find solutions. So the challenge has been laid, and therefore it's up to the engineers on this webinar and hopefully more widely to find the solutions. I do have some relevant experience in the subject, so I have been involved in a number of initiatives, number of points, so I do understand the constraints and challenges that are associated with the program. Why are we talking about a net zero elephant? Well, there's an African proverb which is, how do you eat an elephant? And the answer is one bite at a time. All right, and I just felt that was appropriate for the challenge here, because I hear a lot of people talking about, oh, it's too big, it's too challenging, and how do you do it? Where do you start? And so on. So I thought, well, let me break it down to one bite at a time. I've listed a number of bites here, and I'll go through these details during the workshop. But my intention is to come up with practical solutions which I believe can be applied at many operations. I will then also talk a bit about corporate strategies and then wrap it up. My intention today is to talk for about 20-25 minutes and then pass it over to the everybody on the program for them to be able to ask questions as they wish. I'm going to provide slides with lots of details. Don't worry, I won't go through the details. My intention is just to provide some backup to the statements. So first of all, with regards to what does the mining and metal industry contribute to global greenhouse gases? Well, obviously, we're all very familiar with the fact that mining and smelting are very energy intensive businesses. It takes a lot of effort to get rock out of the ground and convert it into a useful metal. Also, with coal mining, we've got to consider about the impact of the methane that is emitted alongside with the coal mining. Whilst this talk is mainly going to focus on the mining and processing side of things, it is also important to understand the impact of the smelting to the overall emissions, because these are going to be linked. There may be changes to the mining processes which are necessary in order to facilitate changes to the smelting processes. So I believe we have a role, and that role and that responsibility was also echoed by the ICMM in 2021, which the members agreed that they would target net zero by 2050 and would also aim to implement plans to have a significant reduction by 2030. For those of you who are not familiar with the greenhouse gases, one of the key ones, of course, is water and clouds, but obviously that has always been around and we're quite happy with that. The key ones that we need to focus on are going to be the carbon dioxide and methane. There are also a number of other fluorocarbons and nitrous oxides that are around, but most of my talk is going to be focusing on carbon dioxide and methane because that's what most of our activities can influence. The other areas are more specific to certain types of industries. Different greenhouse gases got different impacts, and they have different impacts over different periods. A key thing really for me is that methane is roughly has an impact of 80 times CO2. So if you burn CH4 to create CO2 1-to-1, you reduce the methane, the global warming potential from 80 to 1. So to give you an idea of what sort of potential benefits are. Now, mining has got a lot of constraints. The deposit is where the deposit is. We've got to get it out of the ground. We've got to separate the rock, and it's got to be economic. So how are we going to deal with that? So as I said, I'm going to go through this one bite at a time. So the first bite is the easy one, which is basically use low carbon electricity. So your renewable energy, nuclear energy, this sort of thing. The great thing about this is the fact that it means that we can get on with our lives. We don't have to change anything, and all the reduction in emissions happens elsewhere. So as a result, companies can continue tomorrow the same as the way as they operated yesterday, but now with lower emissions. For many grids, especially in Europe and a number of countries, they are already making significant progresses towards reducing emissions. The UK has reduced its emissions from the grid by 80% in the last 10 years. But companies can also make significant impacts by either building their own renewable plants or signing power purchase agreements with companies to supply this renewable energy. I've heard a lot of people say, yes, but, isn't this renewable energy a fad, because, the sun doesn't shine at night, wind doesn't blow all the time, etc. Absolutely. The renewable energy is not a guaranteed reliable baseline power. However, it is a fantastic option. It creates an opportunity for being able to include into the mix a large percentage of renewable energy. So a lot of countries now, over 50% of the power is currently coming from renewable energy, which is then enabling a significant reduction in the emissions. In order for that to happen, you have to have a flexible grid. You have to have your grid system set up so that the power is transferred from where it's generated to where it's needed. So there is a lot of change required, but a lot is happening. Another question, but doesn't it cost money? Well, it used to, but nowadays the cost of a solar power and for wind, onshore wind, is cheaper than anything else. Also, I was reading a report today about the potential rollback of renewable energy in the United States. And what one of the operators said, well, the facts are, I can commission a wind system within a year. I can commission a solar system within a year and a half. It takes me 4 to 5 years to get a gas power station going. So it is just simpler. It is easier to be able to bring in a lot of renewable energy. So there is a lot of momentum towards this. As this said, you have to then still spend money on changing the grid, which needs to be recovered. And at the moment, you also, depending on the grid system, you need to consider what is the cost of producing the last megawatt. At the moment in Britain, for example, that's gas, which has pushed the price up since the Ukraine crisis. But with having a lot of renewable energy in the long term, the cost will go down. The second bite, improve efficiencies. Now, everybody loves to improve efficiencies. And there are a lot of areas and opportunities for it. However, as a consultant, one of the things that I see is I feel that a lot of companies have yet to fully harness the power of data. They're largely using their systems to be able to capture information about what they do and do the same tomorrow just more easily, rather than using the data to be able to change things, such as understanding where potholes are in the road fixing those, understanding which vehicles are sick and fixing those, understanding what is the opportunity to improve some of the recoveries. So there's a lot of opportunities still available. Moving on, transportation is the main source of the Scope 1 emissions. And for open pits, this is a very significant portion. So therefore, obviously, if you can change your technology, you may be able to reduce your emissions. Now, the first group here, they need to have low emission electricity. There's no point moving to a trolley assist system if it's being generated by coal. The electricity is being generated by a coal power station. So you need to have low emission electricity. Renewable diesel is a good option. It works. It is as efficient as fossil fuel diesel. In some cases, it's cleaner and better, but it's available on a limited scale only. Also, implementing some of these systems require changes in the mine, may require changes in the mine plan, mining sequences. So there's a number of things that need to be thought about, and I'll go through some of those points now. With trolley assist, what I find is a lot of people don't understand or aren't aware that the wheel motors have actually got more, they're rated to be more powerful than the engines because they've also got to stop the vehicle as quickly as possible. And therefore, one of the key benefits of trolley assist is the fact you can then fully utilize the power of those wheel motors. And as a result, the trucks can now travel up the ramps much faster. So not only are you converting diesel to electricity and therefore reducing emissions, but you're also getting a significant benefit from reducing the cycle time. And that in its own can be a significant benefit and worthwhile, irrespective of the impact on the emissions. Conveyor systems also, they are inherently more efficient than truck systems. Because a truck, 45% of the gross vehicle weight is the steel and rubber of the vehicle. So every time you're driving up and out of the pit, you're moving a lot of steel and rubber unnecessarily. So a conveyor system is more efficient, even with the crushing taking into account, because the crushing is coarse, you only need to get it to about 300 mil. The amount of effort involved there is not that significant. So here's a comparison on a hypothetical operation, a 200-meter deep hole out of a pit. So as you can see from this, yes, the capex is going to be higher, but you're going to be getting benefits in terms of the OPEX and the emissions. So there's a lot of opportunity for the operations which are appropriate. So what do you mean by operations which are appropriate? So here is a mining sequence based on the typical pit optimization. So blue is best, green next, yellow, red, etc. So with a diesel system, I could mine it in that sequence, no problems. I don't have to do much thinking. When I want to put a trolley assist or a conveyor system in, I want to ideally have a nice long wall, and I don't want to move the facilities around much. So one thing I could do in this case is I could combine some of the mining sequences to be able to get the final wall defined earlier. Or I could move it to the short wall in order and put a high angle conveyor system in. So obviously, these are changes to the mine design, changes to the mine plan, but they're all perfectly possible if you're aware of the option. Hydrogen fuel cells, well, the first truck was commissioned in 2022. There's been more since that. The great thing about hydrogen fuel cells is that they can refuel quickly and that they can have a long operating time before refueling. The downside is that they are creating hydrogen is inefficient. So it requires you to have surplus electricity to cope with that inefficiency or good access to hydrogen, and you also need to have water. So what about battery electric vehicles? So for open pits, there has been a phenomenal change in technologies, and the energy and the work being done is amazing. So a few years ago, a number of the big companies got together and said, we're willing to put some big money down to have the major OEMs produce a battery electric truck. Now, anybody who's any mining engineers on here will know that Caterpillar have always prided themselves in producing mechanical drive trucks. Well, now they've had to go and embrace the electric drive business. So they have spent a lot of money, supported by the mining companies, to invest in these battery trucks. So the ones that are running at the moment are prototypes to learn from, and then there'll be a second generation, then there'll be more, and then they will go from there until the production. So many of the mining companies are expecting that these will be in their operation from 2027, 2030. So not that far away. The great thing about a battery electric vehicle is that you can do exactly the same as what you do with a diesel vehicle, but now on electric. However, a battery doesn't get you very far. Taking a big haul load up out of the pit is going to be drain the battery very quickly, and therefore it's quite likely going to be needing to pair this up with a trolley assist system, which then can take over the heavy load. Plus, you could then also use it to charge up the battery. So put a trolley system on the flat and not just on the uphill. They're also now looking to go a few steps beyond the Tesla supercharger, and now they're looking at a 6 megawatt charger, which can then recharge a battery in less than 30 minutes. However, with these batteries only being available to work for 1.5 to 2 hours, unless you have a trolley assist system, it is still a work in progress. So what do you go for, battery or fuel cell? Well, as always, it depends. So as I said, the fuel cells are less efficient unless you can have some of these advantages by having hydrogen or other factors available. So as always, it's going to be you need to look at it for your particular operation. So moving on to the fourth bite, changing the technology. So there's a number of opportunities and options available. The ore sorting or pre-concentration, there's a lot of technologies available that you can sort at the shovel, you can sort in the truck, and you can also sort in the processing plant. High pressure grinding rolls they require less energy, and therefore they can improve that. And then moving to leaching systems. So there's a lot of opportunities to be able to reduce the emissions. Underground, in many aspects, they are more advanced in the open pits and the transfer over to electrification. There's always been the tethered options for all of the equipment, so that's easy. But now, obviously, you're now starting to get battery electric vehicles as well. Being smarter with ventilation is also helping to reduce, and by transferring from diesel to electric, you'll obviously need less ventilation, and therefore that has a significant saving. And then, use of real estate, you've got space underground, and some operations are looking at moving their processing and tailings underground. So how do I decide between these various options, which one gives me the best bang for the buck? What do I need to do? Do I need to do 2 things, 3 things, 10 things? What do I do? So one of the challenges with projects is that we always have been trained to come up with the best economic solution. How do we deal with it if there's a second criteria? So one is to be able to apply a shadow carbon charge if there isn't already a direct carbon charge, so that there is a cost per ton of CO2. So you can then now convert your CO2 as an emission, convert that immediately into a cash cost, and therefore you're back to having NPVs and IRRs. So a number of companies apply their own shadow carbon charge to help them with making their decisions. Some companies also produce these marginal abatement cost curves. So here's from the Glencore reports. So they've identified a large number of projects. They've looked at what the economic benefits of them are, ranked them from the most economically attractive through to the least, understood what is the impact on emissions, and therefore they can then look at that and say, well, This group here, I can justify economically. I don't need to think about the emission side of things. It's giving me a positive impact on the MPV. This lot, look, it's pretty neutral, it's marginal, but from a strategic perspective, it's not going to cost me anything because it's going to be improved. Okay, there may be some capital that is going to be allocated to less economic projects, but there is finance available for that, whether you get it from banks or whether you can get it from company IFC, EBRD, and some of these operate organizations. So it is actually, there are keys available to unlock the finance for this. And as a result, you can get a significant benefit. And then if you put a carbon charge in, well, actually, that's even more. So now suddenly we've got 80% of the opportunities are now potential to be implemented. Okay, I'm interested. So how do I do that? Well, here's our scope 1 and scope 2. So scope 1, it's mainly about diesel. 1 litre of diesel, 2.69 kilograms of CO2. Calculate how much diesel. You've now got a calculation of how much CO2. Simple. Electricity, it's a bit more complex because your grid system might be getting power from a range of different sources, so you need to work it out, but that's not particularly difficult, so you can do that. And obviously it may change with time as the grid moves towards renewable energy, but that's all possible to do looking at the tables like this or getting information from your supplier. Whilst there are other measures, I would recommend keeping it simple and focus on these because these are going to give you answers for the vast majority of the questions that you need to address. Methane, if you're a coal, obviously this only applies to coal miners, which is why I've got it as a 6A because it's only relevant to certain companies. It's a very powerful greenhouse gas. As I mentioned, in the short term, it can be 80 times more powerful than CO2. And if you capture it and burn it, you immediately convert it to CO2. And even without capturing the CO2, you've now gone from 80 times to 1 times. So a significant improvement. For underground mines, they've been looking at this because obviously it has a safety impact. And in some countries, it's quite easy to be able to extract the methane. In some countries, it's very difficult. However, options are available. For open pit mines, this has not been a key topic. However, satellites are showing that there is significant amount of methane being emitted from open pit mines, and therefore it's going to be necessary to look at some pre-drainage options to be able to try and capture that methane before it is exposed, so that way you can reduce your emissions. So this is an area some companies are looking at, not as many as I'd like, but some are looking at, but it has potential to have a significant impact on reducing emissions. Some rock types contain magnesium silicate, and that naturally weathers to magnesium carbonate. Many of you will probably have heard of the Mount Keith operation, which estimates that they're capturing 40,000 tons of CO2 annually, which, as was highlighted by Samantha Langley, is essentially as planting trees. And and as you can see from this image, it's pretty much in the desert. So imagine you've planted a new forest in the desert because you've got something absorbing this much CO2. So this is all possible. Now, one of the opportunities is to look at how can I capture more, because that 40,000 tons a year was just accidental. They measured it, and without changing any of their processes, that's what they were capturing. They're now looking at other options, such as turning over the surface of the tailings dam using machines to expose fresh material. But you could also introduce air or CO2 at an earlier stage in the process. So there's a lot of options available, and there's a lot of opportunities. And essentially, this is free. It's very easy for those operations with the right mineralogy. For those operations where they've got a point source of CO2, such as a cement plant, then having a carbon capture system is an option. And it's a good way of being able to take quite significant amounts of carbon dioxide out of the atmosphere. It obviously helps if you've got somewhere to place it. So operations near gas fields have got that opportunity available, but there are also other ways, and that's where the use comes in of converting it into something else which can then be used. Looking at the downstream side, as I mentioned earlier, the smelters are a significant emitters of emissions, up to 40 times more than the mining operations. So a number of companies are looking at how to be able to switch from using metallurgical coal, for example, to using natural gas or hydrogen and using electricity to be able to smelt the rocks. I'll talk a bit about that in a moment. The other option is that people are looking at moving from pyrometallurgy to hydrometallurgy, bringing in various leaching solutions to be able to recover the metals that way instead of going via smelters. So what are companies doing? So this was a summary of a number of companies done by McKinsey a few years ago. As you can see, a large number of companies have committed to identifying ways to reduce emissions by 30 to 50% by 2030. Some of these are absolute values, as in I was using 1,000, I'm now going to use 700. And some of them are intensity. I did have a use of 10 tons, and now I'm going to reduce it to 7 tons of CO2 per ton of copper or whatever being produced. So, for example, BHP, this is their program. As you can see, they're looking at the electricity, the diesel, methane, other solutions, and they're coming up with steps. So they have made good progress so far on reducing the emissions from electricity through the adoption of renewable energy. As far as the reduction of diesel, they expect that to come with time. So like from 2030, as the electric vehicles come in. The methane from the operations is an area which they still haven't found strong solutions for. But one of the key things that BHP and Rio as well are looking at is to be able to look at how to convert the steel making processes to so that they can reduce their emissions. So the amount of emissions from the steel being produced from the iron BHP cells, as you can see, is 40 times more than their entire emissions for all of their operations. And they've set a target to help develop technology to reduce these emissions by 30% by 2030. So they're looking at the number ones for current systems, new technologies. So this is some of the actions that are being looked at. Rio Tinto have got a similar program. They've made some recent big changes in terms of reducing their emissions, but through the power purchase agreements for their Gladstone aluminium smelters. They feel that they've got more to do in the Pilbara, but they need to get permissions to do that. The adoption of battery electric trucks, they think, is likely to only come after 2030, which is why you see some of the reductions then. But they feel that on the processing is going to be one of the key areas that they will reduce their emissions going forward. Newmont, similarly, with looking at how to reduce the emissions associated with electricity or with the diesel. So a lot of it, as you can see, is this switching to power purchase agreements, and then it's going to be adopting these new technologies. But one of the key things is that they expect that they'll be building carbon neutral mines from 2030 going forward. They're also looking at a whole range of technologies. So what's available today, what could be available, it's available today, but can be applied in a different way tomorrow, and what is new technology which needs more research. So I want to build a low carbon mine. There's a few companies who are looking at it. Los Azules is a key one that is being looked at. Obviously, your ability to be able to come up with a low carbon operation depends on a whole range of factors. So it depends if you've got low carbon electricity, depends on the shape and geometry of your pit, etc. So there's a lot of things that need to be thought about in order to be able to come up with a low carbon option. And what are the obstacles? Well, there's the technical obstacles, of course. If we're underground, so yes, there are vehicles, battery electric vehicles available, but at the moment, for example, with Sandvik, they've got one battery electric vehicle, or LHD, and they've got 3 tethered electric LHDs, but they've got about 10 diesel diesel LHDs. So therefore, the range available as far as sizing and so on is still limited, but it is coming. The adoption of the ventilation, once you've moved over to having less ventilation, it can also be a challenge in being able to bring in diesel equipment to be able to maintain production if there are delays in supplies, etc. So there are challenges there. A lot of operators in open pits, they don't like having electric drills and excavators because of the effort involved in relocating them for blasts. The technology is available, it's been available forever, but it's been the loss of flexibility. Now, these are options. This can all be got around with good planning and good engineering, as well as some extra work. So, these can be got around. For the process plant, you have great opportunities at the design stage, but once constructed, changing your mill system to high pressure grinding rolls, it would be expensive and difficult. The next area is more the transition from the corporate plan to the site action plan. So as a consultant, I can see that many of the major corporates, they're doing a lot of work in-house internally in this area. However, we're not seeing that many studies coming out which are indicating the transition from the corporate office to the sites, or the smaller companies evaluating options for their sites. So we see that there is going to be this disconnect, and that there's an opportunity to resolve this. So there you are, nice and swift. In summary, there's significant potential. One of the best things I think that's come out from this process is the fact that the mining industry is traditionally conservative. All right, I've been in the industry for 40 years, and the adoption of new ideas, well, not really sure. Now suddenly they've gone to be implementing the fastest rate of change that I've ever seen, where they're wanting to reduce emissions by 30 to 50% within a 8-10 year time horizon. That's a massive change. It's a massive rate of progress. But one of the things that has also been found with this process is by asking the question, how can I do things differently? It's identifying other opportunities which are helping companies reduce their costs. So it has not just been about emissions. It has also been something which has evaluated or identified a lot of improvements and opportunities. At the moment, we can still see plenty of opportunity. We're seeing, as I said, I think there more can be done to evaluate options, especially at the pre-feasibility study stage. And as far as the politics globally, and the impact on whether that is trying to reduce the innovation, that's not working through just yet, because there's so much momentum behind these transitions, and people can understand that politics only lasts for a certain period of time, whilst the greenhouse gas warming is going to be for longer. So at the moment, we're still seeing that. So I hope that this has been of interest. And remember, if you want to eat the net zero elephant, it's one bite at a time. I hope that was a good introduction. Thank you. So if you have questions, put it into the Q&A.
Yep. Thank you, David. Yeah. Anyone have any questions out there? Please just type them in. Yeah. The one I think what you finished up on is like, all these corporate plans on how they're going to, reduce their emissions, but I suppose it's getting the rubber hitting the road, so to speak, and actually getting them implemented. Do you think, the chances of them actually hitting a lot of those targets are good, or,
I think that's there's some of these targets are being redefined, and some of the targets are challenging. But I think that that's missing the point. I think the key point is that people are aiming for these targets. There is ambition. go for this. So even if they only achieve a 25% reduction by 2030 instead of a 30% reduction, whilst obviously for the planet, we would love to see more because to reduce the emissions, it's still a hell of a lot better off than where they were. And then you will find that there's a lot of momentum to keep going for it. Will they get to net zero? Don't know. However, the journey of discovery is going to identify opportunities. And if we get 60% of the way there, that is still a significant advance and a significant program. So I think in that aspect, it is, there are some significant changes. Mark Flanagan just popped up, looking at the transition from open pit to underground. Absolutely. That's going to be one of the options. So when I do the evaluation of, do I do cut 4 or cut 5, or do I go underground at the end of cut 4? These are going to be key options that people need to evaluate. So looking at the in the chat, so James is talking about the mine where they don't have to charge the trucks as the ore is uphill processing. Yes, there's several operations like this. So where they happen to have this opportunity that they've got to take the material downhill, then this is absolutely perfect for electric. In fact, one of the challenges in some mines where they've got downhill loaded hauling is the fact that electric braking without a battery is not as efficient as being able to do it on a mechanical basis. So by having a battery and being able to put it into the battery, fantastic. This is an area which is a great opportunity. So these are the sorts of options that people need to be looking at it.
One question I probably have is that there's, I suppose, it's like the trucks going from diesel to electric. Is there much of an appetite to actually sort of changing how we mine rather than just going, basically doing it the same way, going from, diesel to electric, or, I like underground mines in Australia here, there's a lot of decline haulage, so I suppose changing to more conducive technologies that would make the shift easier.
So appetite, there is options. So as always, the reason why Australia moved to decline haulage was because of the faster access to the ore. So rather than waiting a lot of time to be able to get the shaft to the bottom, then do the development, then do the mining, the getting in with the decline got you to ore faster. So from an economic perspective, it was a much better solution. With the electric trucks, there's the Karuna trolley system for underground has been around forever. So you could still have that type of solution. There are now updated versions of trolley options available. And the conversion of the trucks to be able to run off that, because a underground truck is essentially a diesel electric truck. So the engine generates, powers the wheel motors, then that's fairly straightforward to do it. Obviously, if it's a mechanical drive, then you'd have to change the equipment. But underground equipment is changed quite frequently. So it is something that you could transition to over a number of years. So there's a lot of opportunities to be able to do that. And obviously for a new mine, you could also look at the different options. I see in the question, the Q&A, said James from Always Carbon, have you considered on-site biochar for carbon removal? Well, as I said, these are all options. So it depends on the access to having that sort of biochar available. The great thing about biochar is the ability to lock in some of the carbon. So I'm more familiar with biochar in helping to put more into the ground and to help with the productivity in some rainforests and so on, because of it can improve that. But again, these are all options that people can look at for to find solutions. So yeah, so there's one from Pierre Federici about rope conveyors transport dirt downhill to the plant and generate electricity. Absolutely. You know, whenever you've got a downhill haul, you've got an opportunity to generate electricity. Now, obviously, that's a side benefit, and it's a nice option. So a lot of companies are doing it for those reasons. But if it's the benefit which helps tip the scale towards that solution versus another solution, because as I mentioned, one of the key obstacles to adopting is from an operational point of view, it's a hassle. From a corporate point of view, it's some extra capital that needs to be invested. So sometimes you just need that little bit of hurdle energy, just a little benefit to be able to enable a solution to be found by saying, well, this will also give you this benefit. And what else is going to allow you to achieve that? Oh, this is easy. Because it's easy, I can let people then move to it and it gets adopted. So, you know, there are options available, and it's just a matter of people looking at the options and deciding what's appropriate for their site.
It's sort of choosing from all the different technologies and solutions available to what fits the application, be it open pit, underground, whatever, how they can apply. Yeah.
Absolutely. It's not one size fits all. Each operation is different, but at the same time, each operation can share similar characteristics with other operations. So there are often opportunities. There will be some mines where the solutions and options are minimal. But there are a lot of operations where things can be done differently and can help reduce the emissions. You know, I haven't touched on here some of the other benefits in terms of, you know, well, in Australia, for example, you've got a carbon budget. So if you want to start a new mine and you're emitting a certain amount of carbon, you may not be allowed to. It may become a permitting constraint if you don't have solutions for it. I've not touched on the fact that financing, you know, may require you to have a program to reduce your emissions. So there's a lot of other aspects which will, you know, people need to consider to be able to identify the ways forward. So I think, you know, as I was mentioning at the end of my presentation, this is more than just about, you know, trying to find a reduction in emissions. It's exploring options and solutions and finding out what are the benefits. And you can be surprised as to the wide range of benefits that you can unlock.
Yep, exactly. Thank you. Are there any more questions out there? Just before we wrap things up. I think that might be just about it, Dave and everyone.
No problems.
No, thank you. It's like, yeah, look, you covered a lot of ground, but it's all, you know, it's great to get the whole the picture from, you know, the whole cycle. Yeah, so just want to say thank you for dialing in from the other side of the world, from here in Australia, but yeah, that's much appreciated.
No problems at all. Happy to share the knowledge and for you know, to also listen to everybody else's views, because there's a lot of different opportunities here. We're on a fantastic journey exploring things. It's, you know, the industry has suddenly gone from being conservative to being curious, and long may it continue.
It's probably tying in with probably what you've covered tonight. We've got presentation in 2 weeks from the ICMM on pathways to decarbonisation. So it's probably be a bit of a crossover, but I think it's the exact same time in 2 more weeks. So yeah, because there's probably more of an emphasis being put on that from those types of bodies to, you know, yeah, make that change.
Yep.
All right. Well, thank you everyone, and yeah, much appreciated.
A great day.
Cheers. Thank you.